And in fact, there are these focalized ejections that occur halfway between the corners of the building. Also, say this was the open office space, right, 60 feet long. The elevator hoistway is over here. The piston's going to shove the air into this room. It's going to fill the room fairly uniformly with air pressure before it breaks any windows, right? And then it might break several, but not these highly focalized, pinpoint accurate, geometrically precise, violent ejections. No, it's extremely unlikely. But let's look at a couple of them here.
As the South Tower begins to explode, we track two squibs near the bottom of the frame. They shoot out quickly at first, then slow and merge in with the rest of the dust cloud. Using the first few data points, we see the first squib shoots out at 44.98 meters per second, or about 100 miles per hour. Doing the same for the second squib, we get a speed of 56.3 meters per second, which works out closer to 126 miles per hour.
126 miles per hour of almost instant ejection velocity? Does fire create that? Do we have a near free fall pace through the path of greatest resistance? Let's take a look.
Galileo's law of falling bodies calculates the time in which an object will travel a certain distance in complete freefall. Distance, d, equals 16.8 times time in seconds squared. The South Tower was 1,362 feet tall. 1362 equals 16.08 times 84.7, or 9.2 seconds. The Twin Towers came down in nearly free fall speed.
What are we talking about here? Let's just try to put this in perspective with this story problem. We have a 15-story building which we hold with this crane over 95 stories of nothing but air. No resistance, right? Just air resistance. Next to it, another 15-story building held over a 95-story building with, say, 80,000 tons of structural steel in it. Now we're going to pull the lever on these cranes and drop them both at once. I brought a 95-story building with me today. And we're going to just test this theory of NIST's. I've got two 15-story buildings. We've got 80,000 tons of structural steel in this one right here. And we got air resistance here. So let's try it, okay? We'll put them both up here. We'll even give a little bit of impact load too, okay? Ready? 3, 2, 1. Oh my God, the one without any resistance under it hit the ground first at virtually free fall speed. This doesn't take much, does it? What happened over here? The building above it met resistance. Through the energy of deformation, it came to a halt. In fact, you'll find on our website, ae911truth.org, that Ken Cutler and Gordon Ross produced these papers, and they show and calculate that, in fact, the building's downward momentum would have been almost immediately arrested. Where is the 15-story building that was driving this building down to the ground at free fall speed? In the first 2 seconds, you saw it reduce half of its mass. It was blown outside. It couldn't have been used to influence the downward progression of the building. In the next 2 seconds, after 4 seconds totally, it's destroyed itself. There's nothing crushing the building. It's tearing itself apart at free fall speed. And it's dismembering the steel structure. In fact, the leading edge of these mushroom clouds are full of perimeter columns, aluminum cladding, and other steel. Let's take a look at the South Tower in terms of dismemberment. See what's going on here. South Tower's on your left. It was hit lower by the aircraft. And as you can see, its rapid destruction starts there, and it begins to tilt to the left. And it disappears into this cloud. We would expect to see this building, which is already tilted at 22 degrees and continuing its angular momentum, off-center of the building below it. How can it crush it symmetrically at free fall speed when it's already off-center? And we don't see it either mangled up in some heap at the bottom down on the pavement. It's been completely dismembered. Let's take a look from below, though. We have asymmetrical damage, and yet there's this symmetrical destruction occurring underneath the cloud all the way around the building like the firemen saw, even though this top mass has already fallen over. Free fall speed. Doesn't make sense to me. Steel frame structure was completely dismembered. There are no large chunks of building, only those shards that we saw of the perimeter structure. Does it look like a gravitational collapse to you? Do we have a lateral ejection of structural steel? Let's take a look.
Now let's look at the collapse of the Twin Towers. We are seeing explosions rather than implosions, a first in demolition history. A sequenced rumble becomes a roar as debris is thrown outward. The damage is not contained. Windows are blown from neighborhood buildings. What kind of energy enabled this? Would fire hurl metal and concrete sideways into the air? Here, a chunk of steel was flung 400 feet, wedging itself deep into 3 World Financial Center on Vesey Street. A FEMA photographer taking pictures of Ground Zero wondered why so many steel beams were jutting from neighborhood buildings. What shot pieces of the towers all the way across the street?
In fact, the portions of the tower that had the greatest structural members, the sky lobbies and the mechanical floors, had the perimeter units thrown farther than the perimeter wall units from the upper floors, which theoretically should have, because they're higher, they should have gone farther, right? No, these perimeter units landed on the Winter Garden 600 feet away. Let's take a look at the physics of this.
Girders weighing several tons were found 600 feet from the base of the North Tower. How fast they were ejected depends on where they originated. If they came from high in the building, they were thrown outward at about 50 miles per hour. If they came from lower down, the speed had to be even greater. Gravity alone cannot account for such high lateral ejection speeds.
In fact, let's take a look at a couple of these specific ejections.
Using special software, we can analyze motion on video clips frame by frame. I have placed markers on each frame so we can track a particular projectile. From the markers, we can get a data table and plot various graphs. The data here shows that the object we were tracking was shot horizontally at over 70 miles per hour. The energy needed to hurl a 4-ton girder at this speed is comparable to the energy needed to hurl a 200-pound cannonball 3 miles.
What about those floors, those pancakes? This is a pancake collapse. We're looking for some pancakes down below. This is a 7-story lobby. There's about 2 or 3 stories of stuff in there. We'll take a look at that stuff, but what I'm looking for is 110 floors with this kind of metal decking underneath 4 and 5 inches thick of concrete. An acre in size, each of them. 110 acres of these. How many floors do we find down at the bottom? Not 50? Not 10? Not even 1. We don't even find metal decking down there, or concrete. There's hardly any macroscopic chunks of concrete. What happened to the metal decking? What happened to the concrete? Tom Patrizio brought these floor decks out. 6,000 of them, he says. I couldn't believe it. Not one floor panel, he notes when he comes back to help the cleanup. Pancakes occur in pancake collapses. Enormous pyroclastic clouds of pulverized concrete? Well, where is all the concrete, in fact? Let's listen to Jeff King.
One of the most significant things to my thinking that indicates that this could not have been the sort of collapse that we are told it was is the presence of the dust clouds. And as you've seen in the pictures, and I'm sure all of us have seen probably more than we would like, there were very, very large clouds of very thick dust that enveloped the area, that crossed the river, that made it almost all the way to New Jersey from the pictures that I've seen. This type of flow is something that we are familiar with in physics. It occurs in only two situations that we know of naturally. One is in volcanic eruptions, where a large amount of material is suddenly exploded into the air and basically forms small particles.
Thank you, Jeff. How about New York Governor Pataki?
And you look, and you see, and there's no concrete. There's very little concrete. All you see is aluminum and steel.
What happened to the concrete?
The concrete was pulverized, and I was down here Tuesday, and it was like you were on a foreign planet. All of Lower Manhattan, not just this site, from river to river, there was dust, powder, 2-3 inches thick. The concrete was just pulverized.
And how about this firefighter?
You have 2 110-story office buildings. You don't find a desk. You don't find a chair. You don't find a telephone, a computer. The biggest piece of a telephone I found was half of the keypad, and it was about this big. The building collapsed to dust.
And this dust made it almost across to New Jersey, across the river. Thick, billowing, laying a carpet of 4 to 6 inches thick around Lower Manhattan, pulverized to 100 micron to 10 mil particles, almost like talcum powder, some of it. It's very, very fine. Where's the grinder that produced this? 90,000 tons of it. In these clouds that expanded 10 times the volume of the buildings themselves in just 30 seconds. Now, the available gravitational potential in the whole building is about 110,000 kilowatt hours. That's basically the weight of the building times its height above the ground, evened out. But the expansion of these clouds has been calculated to require about 10 times that energy in heat, which produces that expansion. So we have a problem here. In fact, the gravitational potential of the entire building needs to also produce 4 other heat sinks. But first, we have a 15-story building. This part of the gravitational potential alone, it's converted all of its gravitational potential into kinetic energy. It can't do any more work. In other words, it can't fall at free fall speed and then also crush 80,000 tons of structural steel. It can't fall at free fall speed and also grind up 90,000 tons of concrete. It can't fall at free fall speed and create by friction or anything else the several tons of molten metal seen by the first responders. The energy doesn't add up. We're talking overall about 50 times the gravitational potential energy of the building to produce all of this phenomena. How about the victims?
In April 2006, New Yorkers were distressed to learn that bone fragments, human remains from 9/11, had been found on the roof of the nearby Deutsche Bank building.
And how, in God's name, did those fragments get there?
And bone fragments less than a centimeter long. How could they be so small?
700 bone fragments, a half an inch long, found on top of the skyscraper across the street? Think about that one. There were 2,749 victims, but only 300 whole bodies were found. 20,000 pieces of bodies found, 6,000 small enough to fit into a test tube. 1,100 victims completely unaccounted for. In other words, no pieces large enough to gain any DNA from, vaporized. 200 pieces were matched to one single person. Can fire and a gravitational collapse account for this massive pulverization of people? We talked about the iron microspheres. We talked about the chemical evidence of thermate in them and in the slag and the ends of the beams. And we talked about evidence of thermite in and unexploded thermite in the dust itself. All of this is direct evidence of explosive destruction. And none of it can be accounted for by fire. Let's have Dr. David Ray Griffin sum this one.